Hello. Today I'm gonna talk a little bit about the TDC torpedo data computer for the balao class submarine, but it was also used in the Gator and so on. What I want to present is that I implement the fully functional TDC, including the position keeper and angle solver. I used the ordnance documentation for the specific type of TDC, which I found it was for Mark3. Unfortunately, I didn't find the documentation for the Mark4 because in that case we have additional stack which provides some information from the radar and so on. But yeah, but still, let's see how works just Mark3 TDC. We have to choose, for example, to demonstrate how position keeper works. We can, in original documentation, we can switch to position keeper in tester mode. Yeah, tester mode means that time how to say time motor doesn't work. Yeah, and we can set some values. And as you can see, in previous version we had to rotate our point of view to specific angle to be able to align our pointer which in the center with the some pickable object. But now we can press Ctrl and just move our cursor, mouse cursor, and we can rotate anything without changing the angle of view, yeah, and position. Okay, generating. Okay, as position keeper in the testing mode, yeah, I'm not sure I'm right, but just for maybe a presentation, I will choose some values. Actually, I tested with uh, TDC with how to say testing problems. Yeah, I found for 13 testing problems for position keeper in manual. Yeah, I checked them. Yeah, and everything works not fine, but with some inaccuracy, because I found that mechanical computer is completely different with the real computation, and I found that this computation can be even have some inaccuracy because of the longitude position in because our how to say our globe is not the plate but some globe, yeah, and that's it. Okay, I picked some values, yeah, and now I wanna choose position keeper. Yeah, as you can see, some computation occurs. Yeah, what we have? We have the our course. Yeah, our course. This one. Uh, we can change the input position, input value to TDC by changing the position of mouse wheel. But if we click on Shift, we can change it very fast. Yeah, as you can see. So with Shift, it's changed maybe by 20, but if just small wheel change is 0.5. It's 50 minutes. Yeah. So we can see what this value is here. Also, we can change target bearing. This setting affects only the true target bearing. Yeah, target bearing. This gauge shows us relative target bearing. Yeah. Yep. And it changes, yeah, because we have computation 300. It's not okay. I need to turn our gyro order. The minimal position for shooting is more than 300 yards. It was found in the documentation. So our gyro angle solver will it will I'm not sure, maybe it's not right. Forward shows 700, 500. I don't think it's not correct. Okay, yeah, it's not correct solution. But with 750, maybe, yeah. 18, because target is moving with speed of 10 knots. Maybe. Forward, yeah, it's front of, okay. Yeah. Also, we have the target. I will show it closer. Yeah, we have the relative target bearing, which is also changing. We have the true target bearing. We have time when solution of the problem was started. We have the target course. It changes by input settings. We have target bearing. This one I found with this and this gauge is the same. We show target bearing, true target bearing. This gauge shows us angle of target angle. Yeah, target angle means, if I'm not mistaken, the periscope side angle from the periscope to the target, if I'm not mistaken. But I need to check. Yeah. Also, this TDC can provide solution for bearing, sound bearing problem. Yeah, this gauge, way relates to the sound bearing problem. It's if we have sonar, we have some distance, and relative sound bearing means shows us the position of the target after we have the signal from sonar, because it can be delayed during the sound of speed traveling in water. Yeah, and it shows not the middle position, but how to say, position of the propellers. Yeah, over target. So okay, we probably find some solution for the forward 100. Maybe, yeah, 100. And if we change something, yeah, we have for after. Yeah, I think I have to refine solution. Yeah, because these values are fixed. Yeah, we can change it for now. Yeah, they fixed, and the difference between after and forward solutions with forward torpedo tubes has have the some um, offset from periscope, yeah, and it's different for forward torpedo tubes and after, yeah. Forward have 98 feet and after have 170 78 maybe. These gauges indicates the position of the kill depth torpedo run difference. Yeah, this indicates the kill depth reach. Reach, it's the distance when the torpedo goes straight after shooting, yeah, without changing the angle to the gyro angle, yeah. And gyro angle, it's the angle between our torpedo tube line and the um, target, yeah, target. Um, Also, we can see that for forward torpedo tube, right, starts from 0. 0, 1, it's right, because torpedo goes to the right. If we have more than 180, torpedo go to the left. And it's opposite for the after group. If we shoot from the after torpedo, the torpedo goes to the left if the gyro angle is less than 180. Yeah. Okay, that's all what I wanted to show for TDC. Also, about some progress, I added some tactical map, and for now we can only scale it. Yeah, we have the net 1 degree. It starts from 0 latitude longitude. Yeah, it's we can zoom in minus 10 minutes. Yeah, minutes, and maximum zoom I think will be 10. Yeah, and also I added some, maybe, I don't know, some tools. For now we just can rotate it, and yeah, nothing special. Yeah. I don't know how to use it for now. I'm still learning it. Torpedo Uncle Solver will be added. It's the banjo, if I'm not mistaken, but it's not shown. And also our real position will be how to say, we have dead reckoning systems. Yeah, yeah, let me show it. Yeah, this device. Yeah, dead reckoning, it's just the tracer. So to show our position, I mean, not to show, because we have gyro system, yeah, and the gyro system will show us the current position. But to track our position on this map, yeah, we need to enable dead reckoning systems, because for if we have only gyro, we can see via gauges our current position, which depends on the speed of the boat, the previous position, which was inserted, I don't know, when the patrol was started or something. But to draw the track, we have to enable these motors, yeah, and it will be implemented. Also, we will be able to add some targets. It's not implemented yet, just yeah, never mind. So that's it for today. Thanks for watching. Have a nice day.